Hey guys, welcome to class. So, with me here, we have a very interesting Olympiad question. We'll be solving it together. Now, what you need to do here, since you have 5 raised to power n raised to power 3 and you have the same thing here, what you do, you factorize. So, factorize, we are going to have 5 raised to power 1. Okay, this is what we have. Now, this will now be 1, okay, plus we have 2, then plus 2, all close the bracket, is equals to 1. Now, it seems as if you may not be able to use it to do anything, but just watch out this next step. You see, this is 5 raised to power n raised to power 3. Then this, when you add everything, is 5, okay? So it's not making sense. And this, you are going to have 5 raised to power n raised to power 3, then times 5, of course, is raised to power 1, is equals to 1. Do you know that this is the same thing as saying 5 raised to power n raised to power 3 plus 1? In case you don't know or you can't recall, let me show you this, okay? If you have x raised to power n times x raised to power m, it is actually the same thing as x raised to power m plus m, okay, from the product law for indices, okay, so that is what it is. Then, do you know that I can raise 5 to power 0 to give 1, okay, because anything raised to power 0, if you have x raised to power 0 is 1, so that explains what I've done. Okay, now, for the left hand side to be equal to the right hand side, and here the base is 5, and here the base is 5, we can now conclude that n raised to power 3 plus 1 is equals to 0. So we have an equation here that we are to solve. And how do we do this? Okay, this can be written as n cubed plus 1 cube is equals to 0. Okay, I'll need to show you something now. Just watch and learn. Now, if I want to expand a plus b, okay, all raised to power 3, let me tell you what I'm going to have. I'm going to have a raised to power 3. I'm using the knowledge of binomial expansion now, okay, then plus 3 into a squared b plus 3 into a then b squared plus b cube. Now, if you don't know how to do this straight ahead, I have videos that you can watch on binomial expansion to explain to you. Or else, what you do is just go and expand a plus b into a plus b into a plus b. You are going to get the same answer with this, okay? But I do not have time to be doing that since I can actually do it offhand, okay? So from there, you can now notice that my a plus b cube can be written as a cube plus b cube, then plus 3a squared b plus 3ab squared, which will now be a cube plus b cube, then plus this is 3ab. I'm factorizing now, then I have a plus b. All right, but remember this is a plus b all cube. Now if you check, this is n cube plus 1 cube. Now this looks like it. So if I make this subject formula, I'm going to have a cube plus b cube will now be equals to a plus b all raised to power 3, then minus, we have 3ab into a plus b. All right, so I have a cube plus b cube will now be equals to, you see this and this are common, so I will now bring out a plus b, okay, that is common. This equals to is into a plus b all squared minus 3ab. Now this a cube plus b cube will now be equals to a plus b, okay, then into this is a squared plus 2ab plus b squared minus 3ab. Now this will be a plus b into a squared, then minus ab, then plus b squared. Okay, I just took my time to explain this. It's very, very important. Okay, it's something that you can use for uh, other expansion without, just know it and you do it well. I want to believe this is very interesting to you. Okay, so since I have this, remember what we are dealing with is n cube plus 1 cube. Now, if I'm going to do this, then it's going to be n plus 1 in bracket. Then we have n squared minus, we have n, then into 1, then plus 1, of course, squared. Okay. This recall is equals to 0. Very important. So we are going to have n plus 1, okay, into n squared minus n, then plus 1. Everything will now be equals to 0. Okay, going by what we know from the factorization of quadratic equation, this is going to be equals to 0. Then n squared minus n plus 1 is equals to 0. Now, picking the first instance, when n plus 1 is equals to 0, this implies that n is equals to minus 1. So that is one of the values of n, okay? Then n squared minus 1 plus, n squared minus n, all right? Then plus 1 is equals to 0. Now, using quadratic formula, we know that n will now be equals to minus b plus minus root of b squared minus 4ac all over 2a. Okay, but recall this is n squared minus n plus 1. Then this is ax squared plus bx plus c. Okay, just like comparing coefficients. Okay, so you can see that when you compare the coefficient of unknowns, a is going to be 1, then b is equals to minus 1, and c is equals to 1. So what I'm going to do here is to come, this n is equals to minus, then minus 1, then plus minus, we have minus 1 all squared, then minus 4 into 1 into 1, okay, all over, I have 2 into 1, all right? So therefore, my n will now be equals to 1 plus minus root of 1 minus 4 all over 2, which will be 1 plus minus root of minus 3 all over 2. Now, this is now going to be in a complex plane because this is n is equals to 1 plus minus. Now, this is the same thing as saying root of 3, then you have root of minus 1, okay? This is over 2. Now, we know that root of minus 1 is the same thing as I. So, therefore, n is going to be 1 plus minus root of 3i all over 2. So, n is 1 plus root of 3i over 2, or we have n is equals to 1 minus root of 3i all over 2. Now, in summary, we have 3 answers. We have the first n is equals to minus 1. Then the second one, n will now be equals to 1 plus root of 3i all over 2. Then the third one, n, will now be equals to 1 minus root of 3i all over 2. So thank you guys for watching this video. Don't forget to subscribe. I have a lot of interesting videos coming your way, so don't forget to subscribe. Make sure you continue to watch your maths for very good and interesting math videos. Thank you.